Let's draw some pictures. This first picture, we want it to be continuous and differentiable everywhere. X is negative infinity to positive infinity. So no cusps or sharp corners, no discontinuities in our graph, and no vertical tangents. Nothing that's going straight up. That's what it means to be differentiable. And then the other things that have to be true are listed below. So it says the derivative has to be less than 0 from negative infinity to 2 and 5 to infinity, and bigger than 0 on the interval from 2 to 5. So I could interpret this less than 0. It's the first derivative, so that means decreasing. Bigger than 0, that means increasing. But this is just too much work for my brain. I can't read something like that long sentence, and make sense of it for some reason. So I personally like making a sign chart before I draw a picture. It just helps me to take one piece at a time and break it down. So first of all, the important numbers with the infinities have to be critical numbers, right? We're talking about the first derivative. It can't go in there unless it's a critical number with the infinities. So I have critical numbers at 2 and 5. And then I'm going to take each piece and put it on the sign chart. So this piece says decreasing from negative infinity to 2. So I have a negative first derivative there. So when I draw a picture, I'm going to draw something decreasing. And then from 5 to infinity, I'm going to also be decreasing. And then lastly, my interval between 2 and 5 is increasing. So I switch from decreasing to increasing to decreasing. So I want to draw this shape. And it doesn't give me any points on the graph, so I could draw this shape literally anywhere, and I should be fine. As long as I go decreasing to increasing to decreasing, I'm good. I like to choose points just because I think it's easier for you guys to draw what I'm drawing, so I'm going to choose some random points. What do I have at 2? If it goes from decreasing to increasing, I must have a relative min that I'm supposed to be drawing there. So it doesn't tell me where the graph has to be, so I'm just going to choose a random relative min. My relative min is going to be at the point 2, 1. I just chose it. There's a ton of right answers. And then at 5, I switch from increasing to decreasing. I should draw a relative max there. Then I can put it anywhere I want. I'm going to put it higher than my min because that makes sense in my brain. I'm going to put it at the point 5, 4, just because I feel like it. And there's more than one answer. So the last step is to just connect these. Make it decreasing to increasing to decreasing. Follow that same general shape. So I'm going to go decreasing to increasing to decreasing. I'm going to make sure I don't draw any sharp corners. I'm not going to have any discontinuities. It should all be continuous, and there's no vertical tangents. That way it's continuous and differentiable everywhere, but it went from decreasing to increasing to decreasing, and it follows the information given. There are a ton of different answers on this. So if you weren't thinking of the points 2, 1 and 5, 4, that is totally normal. I literally just picked them right now. So tons of different answers. As long as it's this shape, I would give you full credit. Let's do some more. Ooh, this one we get a second derivative. That's going to narrow down our answers quite a bit. That one we only had the first derivative. So drawing, increasing, and decreasing, that can look a bunch of different ways. As long as you don't have a sharp corner, you're good. But this one, I have a second derivative, which is just going to give me more information about what the shape has to look like. So I want to be continuous and differentiable everywhere. So no discontinuities, no sharp corners, no vertical tangents. And I want to make it increasing and concave up. Increasing because that's the first derivative being positive, and concave up because that's the second derivative being positive. And that is everywhere. It's not on intervals and shifting like the last one. So having concavity is super powerful. It narrows it down to 3 options. So I'm going to do some side work off here. I can't make a sign chart out of it because I'm not having a bunch of different intervals. So I'm just going to do a little side work because I like to try to work my way into knowing what's going on. So this is really all I can do. So concave up is a full U. It could be the left side of the U, or it could be the right side of the U. So there's the second derivative being positive, concave up. Let's figure out which one of these is always increasing. So at first this one's falling, then it's rising. So it's definitely not going to be that picture because it has to be increasing everywhere. The next one's falling everywhere left to right. And this one's rising everywhere left to right. So what's my correct answer? What's concave up but also increasing? Those all three are concave up, but there's only one that's always increasing. I have to draw something that's this shape. I'm not given any points on the graph that I have to go through. So again, I can draw this wherever I want to. I'm going to make it all look positive. So I'm just going to draw a line across there. It's oriented a little bit upward so I can tell it's concave up. You don't have to make it look like a super dramatic U. And it's increasing as I go across. So there's many correct answers. But there's always the potential to get it wrong, right? So let me show you a couple of places where you would lose points. So here are some wrong answers to this, just so you make sure yours doesn't look wrong when you check back at it. So a wrong answer that I get a lot is this. It's supposed to be increasing everywhere. This slope to me looks like it's maybe 0 or negative, so it's not increasing. So don't make yours look too straight. It should kind of look like it's going up, and that's good with me. Another common wrong answer is, maybe you make that side look good, but you go straight up on this side. This is not a function. It has a ton of y values for one x value. So you can't make it look too straight. Those are both common mistakes, the slope of being 0 if it's too flat, and then if it's going straight up, it's going to have like a vertical tangent, and it's not even a function because it's going straight up, so you can't even take the derivative of it. And then making it look too much like a U is another common thing. This is maybe the most common. Like, I get that you're trying to help me, you're trying to show me, hey, this is definitely concave up, and I appreciate it, but if you draw it too much like a U, then it looks like it has a tiny decreasing piece to start, and then an increasing piece. And then this really looks like the slope is 0 because it looks like a soft peak. So you don't have to try to help me out by making it look more like a U than you have to. This answer is perfect. There's a lot of ways to draw this that would also be fine, but just be careful that yours doesn't look too flat, it's not straight up, and that you're not making it so that there's a decreasing part. Some common mistakes. And double check yours, make sure it looks okay. Let's do the same thing. You could try this one on your own if you want to. Pause the video. We're continuous and we're differentiable. And my first derivative is negative. First derivative being negative means decreasing. And my second derivative is positive. So I'm concave up still. So I want to draw something that's decreasing but concave up everywhere. So I'm going to pretend like I don't have those U's drawn above. I always redraw them. I need to pick part of the U that's always decreasing. So it could be the full U, maybe it's the left side of the U, maybe it's the right side of the U. Which one's decreasing? I didn't do the best job at drawing it, but it would be this one here. It's falling left to right, this one's rising, and this one switches from falling to rising. So we're going to draw something that's like this shape on the graph wherever I want to. I drew all on like the positive y values last time, so I'm going to draw where it dips below, and that's fine too. So something falling, but oriented upward. I know it's concave up because if I tried to, I could connect it and I would make a correct like right side up U versus I can't connect it and have it look like a U if it's going down. So it's definitely part of concave up. It's just the only part of the U that's decreasing the whole time. And you could put that anywhere you want to. There are many answers, and I'm not too fussy about how perfect it looks. It's just like if it's blatantly this, it's like no, slope of 0, vertical tangent, can't do it. So just draw a nice smooth curve and you should be good.